So, welcome everybody to another episode of Software Architecture Stream. This time around, we are going to talk about is it all built on sand, and we are going to talk about empirical software engineering. And I'm really looking forward to this episode. And I have two guests. So first of all, there is Laurent Bossavit. Laurent, do you want to say a few words about yourself?
Hi, I'm Laurent. I've always been a software professional of some sort, trying to keep in touch with the value zone where people actually write code. I've also been a consultant, and I've written I've written parts of more than one book, but there is one book that I have written all by myself, which is called The Leprechauns of Software Engineering. And I will be telling more about what that book is.
Right, and our other guest is Hillel Wayne from the States. So do you want to say a few words about yourself?
Hi, my name is Hillel. I've also been entirely a software professional. And these days, most of my work focuses on sort of exploring the fringes of software engineering and trying to find ideas that could be more useful widely, but are for some reason or another undercapitalized. Recently, a lot of that work has been in terms of what's called formal methods, which is proving software correct and making that more accessible. I've also done a lot of work in sort of the history and the culture of software engineering, which I imagine I'll be talking about a bit later too.
And if I understand it correctly, you are actually doing consulting and training with concerning formal methods, right?
Yep. That's basically my career at this point.
So sort of how this episode started was I got a recommendation to read The Leprechauns of Software Development, which is quite a few years back. And for that reason, Laurent, do you want to say a few words about that book, and what are leprechauns, by the way?
So it's very, very late to correct that mistake, but I'm starting to think of the title of the book as a mistake. And I'm not going to tell the story. It's in the book, so you will have to read the book to find out why it's called that. But I should have called it something like a few things that everybody knows about software development, which actually turn out to be false. And the book is about my quest to try to find the actual sources for a number of these so-called facts in software engineering. So things like the obvious existence of 10x developers, people who code, who are 10 times more productive than others, the true story of waterfall, whether defects cost exponentially more to fix as time goes by, or the cone of uncertainty and its use in project planning. So the book is about my curiosity about these things and what I found out when I try to go back to the original sources. It's really a book about advanced Googling skills. That's one way you can look at it. It's a book about how to satisfy your own curiosity. And if it has one main message, it's a negative one. It's to stop looking for grand universal laws of software development. And well, like many things in my life, the book is, I think, a success, but it's a partial success because one thing I wanted to do by writing the book was to train people to do the same kind of thing I do reflexively, having trained myself to do it, which was whenever someone tells me something about software development and nowadays about anything else with that air of authority, to stop and think about what that thing means and try to look for actual data. So I'll just give you two recent examples. I was in a class recently about human communication and how to use that in my work. And the trainer happened to mention something that she was convinced was true, which was a fact about verbal versus nonverbal communication. And she said something along the lines of 55% of all communication is visual, 38% is nonverbal, and only 7% is the verbal content of your message. And in this kind of situation, my first reflex now is to actually go to Google and enter these exact numbers. And it took me about 1 minute of searching to, one, find the source and the original study, which dates back to the late 60s, and also have several people presenting reasons why this interpretation of the numbers was completely wrong. So it's actually something which is very easy to do when you train it.
You know what sets off my alarm bells right there? Two things. One, those exact percentages, like 55% of all communication, as well as the fact that the word communication is so ambiguous. Like, what do you mean by communication? What do you mean by verbal? Like, how are you getting such precise like values with such a vague like metric? And yeah, then I'd probably go on Google and do the same thing.
Exactly. And but it's interesting to become aware that this is not something, I mean, you and I would kind of trigger on those exact same cues and have the same reflex, but it's very much not something ingrained in most people in the profession. But unfortunately, as I was saying, the book was kind of designed, or my intention was to train people to have this kind of reflex and say, oh, numbers, they sound extremely authoritative, which is precisely the reason why I should be questioning them and going to find the data. And oddly enough, the book has produced, in some ways and in some people, the opposite result, which is now that people come to me and ask, oh, do you know anything about research on the relationship between team size and productivity? And what I do these days is I go to Derek Jones's book, which I'll be saying more about in a moment, which is now my go-to source for research that I can live with, or live with quoting it. And I say, no, I've looked in the book, I haven't found exactly what you're looking for, but by the way, why do you ask? And in this instance, the person who was asking the question said something along the lines of, my management is trying to get me to double the size of my team, and I'm trying to find any kind of authoritative research that I can use to convince them not to do that. And
well, in that case, you don't need necessarily good research. If your goal is to persuade like a boss, then you just want any kind of ammunition.
Exactly. So you could very much, you could pretty much make it up yourself. But I've tried to save people from doing that, and I've failed miserably.
I do want to say that, oh yeah, the that kind of issue with like the blind trust in like these things, I think is pretty universal. It's not just in our profession. There's this thing in history about primary versus, are you familiar with primary versus secondary sources? So I can just explain for the audience is that a primary source is like the piece of evidence from that era or time, say like a sculpture or like something that they wrote at the time. And then a secondary source is what historians produce based on the primary sources. And the fundamental rule of history is you always got to go back to the primary source. You do not take anything that anybody says is part of a secondary source as true. You always go back to the primary source. If you read a good secondary source, it is good because it points you at the right primary sources. And that's the same thing true with like research. Whenever somebody claims like 55% of communication is nonverbal or catching defects early, they're essentially being a tertiary source. Always got to go back to the primary source.
Yeah, and I think that is also something that the book, the Leprochauns, I think illustrates quite well, because it takes some papers and looks at how those papers cited some papers, and then there is the original source, and sometimes it's just a group of students that were taken from the university campus and were starters, and then there were some conclusions from that. I'm wondering, I mean, I have to admit, the person that you just talked about, who was looking for some reasons to not have the team size of their team doubled, first of all, to me, it seems like, I could say it's obvious that a larger team is harder to handle. And I would have thought that there is also these things like, if you add people to a project that is already late, then it should even become worse, and it becomes slower because those people have to come up to speed and these kinds of things. So I'm wondering, what you did with that person and what your recommendation would be if I'm in that situation the next time. I mean, it is obviously something that could happen to basically all of us. So what shall I do?
Mm-hmm. Well, I guess my answer to that person, and it would be my answer in general, would be try it and see, rather than rely on the hope that there is, some kind of equation that you can look up that says if you have this many people, then you will have that much productivity, and that's not something you can expect to have generally. So you are in a specific situation, and you have a number of people on the team, call it N0, and if you want to know how much your productivity varies when you're adding or subtracting one person from the team, it should be very easy, right? You would just add one person for a couple months, and then you just measure your productivity, right? So Hillel, maybe you can see the problem with that.
Yes.
But that would be, it would be ideal if things worked out that way. And the whole tragedy of empirical software engineering is why they don't.
Yep.
Okay,
Is that a segue? Yeah.
Okay, so what is empirical software engineering? We've been using that term, but we really didn't define it. So what is it actually, and why is it important?
So empirical software engineering is basically, as Laurent was saying, there's all these things that all these complicated systems and all these things that can affect things. And basically software engineering is this huge complicated mess. I think we can all agree on that. And there's some things that sort of we are more or less convinced by. For example, I'm pretty sure that almost everybody doesn't put everything on a single line. We all agree that that's a bad practice to put your entire code base on a single line. We also sort of agree that you can get decently fast software writing in a high level language. You don't need to do anything in assembly. So this sort of creates this pressure, both from a product, a sense of if we understand this field better, we can do better things, as well as just this fundamental human urge of understanding what we do to try to tease out more of what we know. Is it necessarily true that certain practices lead to fewer bugs? Is it necessarily true that we need to be using, I don't know, a static type system in order to write high quality software? Is it necessarily true that adding people to a late project makes it later? And empirical software engineering is this sort of the entire field of trying to pierce together what we can know factually or empirically about software. And unfortunately, it is very hard and very difficult to do. And we have not gotten very far. And we probably won't get very far in the next century. But we're trying, at least.
So I think there is a good question on the chat by Felix Müller, and that also fits in quite well, I guess. So he asks, is empirical software engineering flawed by design because we cannot compare different complex adaptive systems, aka teams?
So that's often a question, and I'd like to sort of point out two facts about this. One is that there's another system that we have done pretty good research in sort of understanding how to make them better, which is hospitals. I can't quote any of it off the top of my head. I've just talked to some people in that space, and those are also incredibly complicated systems that almost everyone is different, dealing with different issues on the spot with different teams. But they've managed to at least make some progress understanding how to design better hospitals and how to treat patients better. More sort of fundamental to software, even though there are at a broad level, we can't make high level statements does planning reduce bugs, or should we all do this? We can dig into and get some smaller details of things that we're pretty sure do apply. One good example of that is how people learn software. So there's actually been a lot of really good work in software education where people have been doing experiments on different kinds of educational practices to help teach students better. That basically allows us to sort of sidestep a lot of this complex system stuff and focus on a case where even though we have complex systems, we can at least make some progress, useful progress.
Laurent, anything to add, or?
Yeah, there's probably something we can do. I come from the country of René Descartes, and so his method for dealing with that kind of huge, messy, complex problem would be to suggest starting with things that we know for sure, but that absolutely, and things that we cannot possibly deny, like, and I'm struggling because I'm going to cite an example, and just afterwards you will see that maybe that's something questionable. But the one thing I would say applies universally is that software development is the product of human minds. Of course, you're already coming up with the objection to that, which is now that we have GitHub Copilot and GPT-3 models who are able to generate code for us that maybe no longer...
That was going to be my objection, but keep going.
But anyway, you could start from that and say the facts that are relevant to how we program are facts about the human mind, first and foremost.
Maybe I'm trying to sort of ask the opposite question. So one could argue that we are able to study societies and political systems, and there is a whole branch of philosophy that talks about that, and there is sociology and so on and so on. So if I could also ask if we know how to study those societies, and if software is basically a team effort, and then we should be able to just apply those things from the other fields and come up with some conclusions, because it's at the end it shouldn't be that different. So these complex adaptive systems consisting of people, we are studying them for quite a long time. There is a whole body of studies about societies and groups of people and how people behave and these kinds of things. So can we just use that?
I will have three responses to that, if that's all right. One is that I don't know a huge amount about sociology and psychology, so everything I'm saying is coming out of like my nose right now. Two, I'm actually going to skip two because it is snide and irrelevant. It was just going to be a dumb quip. Three, I do think that's actually to my understanding, that's actually a really fruitful pursuit. And what we do there is not sort of like try to do like what people normally think of as like sciences, like clinical trials or like large scale data analysis, but focus much more on deep, like small focused individual studies. And that has seemed to be, at least in my opinion, pretty effective at finding interesting information. There was this talk that just came out at Splash this year. So it was like first like announced last Thursday, where it was called a grounded theory analysis of static type, people using static types. So what happened was the researchers just sat down with 15 people writing code in statically typed languages and observed how they did it. Not to sort of like necessarily say like do they have more bugs, less bugs? It's sort of like, what is their thought process they're going through? And that, you could argue that's just 15 people, but it might not be generalizable, but it still provides really interesting, useful insights that we can probably apply in more cases, understanding how they did it, why they do it. These are called qualitative studies instead of quantitative ones. And I think, honestly, they are a much more fruitful avenue to find actionable, insightful information.
Why is that? Why do you think that focusing on such a group like 15 people and trying to get conclusions from them is the best way or the better way to do empirical software engineering?
Well, because we're not looking for conclusions, we're sort of looking for insights. We're looking for things that spark us to go, oh, that's interesting. Let's learn more about that. We're looking for things that like engender discussion and dialogue. The hard part is getting conclusive facts, like conclusive information where we say like, we know X, we know Y is not true. That is extremely hard for us to do, but it is a lot easier. And honestly, for most engineers reading it, more useful to see, hey, here's a surprising thing we found that people didn't see before, but we found by doing these like really close studies. What do you think about it?
And then I could draw my conclusions and say, okay, this is something that I can apply to my project, or I don't feel like it's going to work in my project, and then I don't do it, or whatever.
Exactly. You can incorporate that insight or those questions into your own complex system.
And I wouldn't be looking for the answer, like the absolute truth, but instead I'm just looking for, let's say, some ideas to try out in my own project. So that's basically what you're saying is the most fruitful thing. In a way, that means that we never know what works and what doesn't. Is that what you're saying?
I don't think it's necessarily that we can't know what works and what doesn't, as much as that's just so much harder and so much more fraught, and we only have finite like lives on this earth. So it's better for us to sort of right now at this stage in sort of the development of like the field, prioritize the stuff that is essentially prioritize the low-hanging fruit, as opposed to constantly trying to reach towards these massive grandiose theories that are extremely hard. I mean, it took like decades to prove that smoking caused cancer, right? Does anybody know the history of that one? It took a while.
So we spoke about qualitative studies. There is also quantitative, and then there is code mining. Is there any value from them, or are they just fundamentally flawed, and we shouldn't care about them?
So quantitative studies are the ones where we're actually trying to get like data, right? So it's where we basically either do what most people think of as a clinical trial, where we have two groups and have them both do a thing and compare the results. And it can also, or it could be something that's more like statistical, where we're basically going through like a number of projects and classifying like what happened in those projects and trying to compare and contrast them. Sometimes this can be really useful. One paper I think I linked later is called is about I think I linked it somewhere in like one of our notes. It is this OSDI paper by Laurent called Simple Unit Testing Can Prevent Most Critical Failures, where they went through a number of distributed systems and found all the outages, all the situations where the entire system went down or partially collapsed, and traced down the results. And they found that in almost all cases, it was an unhandled branch or a to-do that said, to-do fix me. And in most cases, a single unit test would have caught that error. So that I think is an example of a really useful quantitative study. It, again, isn't necessarily conclusive, but it does provide us interesting, these are the kinds of things that bring down large systems. Here's one possible way we can prevent it. It is also very easy to do quantitative studies wrong, where either you're dealing with such a complicated system that you don't really catch all the details. And that's what happens with a lot of the cases that Laurent has like dug into with like, Laurent, do you want to sort of give a brief introduction to Kokomo?
Wow. No.
Okay. So...
Well, that was one of the earliest models for costing and sizing projects, and I kind of regret having loaded my brain at all with any facts about that. So, what did you have in mind, Hillel?
But basically, the guy who did Berrybohm basically took 50 projects, put them into numbers, and then ran a logistic model to say, like, okay, now we know that if these numbers match up, your project's going to cost this amount of money. And of course, everybody from the sidelines is looking at like, what are you talking about? Like, there's so much complexity you elided. Like, these projects are vastly different. You included a NASA probe and like a Tello World app in the same like code base. What are you even thinking about? That's the kind of like, if you're not very careful, like it's very easy to sort of throw in so many confounding factors of quantitative studies that your information is useless. And that's one of the reasons why I think it provides us less insight, is because it gives us, I guess, more air quotes, rigorous information, but it's also gives us a much narrower relation for much more expense. And people kind of don't like that. So they try to like do really wide information really cheaply. And then you just get nonsense because you can't do quantitative studies wide and cheap. And rigorous, wide, cheap, pick one.
So one of the things you learn about statistics, if you care to study it even a little bit, and by which I mean not enough to be proficient in it, not enough to be a researcher yourself, but just enough to be able to criticize studies and people who draw too much, who try to draw too much inference from too little data, is the problem of overfitting. So when you have enough knobs that you can turn and generate a huge number of outcomes, if you try to do things that were done by Beam and others, but I think that they were doing it in the spirit of it's better than doing nothing. It's so in the early days, that search for quantitative models was well intentioned. I think things became more fraught later when it became, or it should have become obvious that the field of software engineering had become so much more complex that you could not anymore rely on inputting the number of screens. And so that's what the drivers in Kokomo were, that kind of thing. So you counted the number of screens, you counted the number of answers that your program could output, like the payloads of your shuttle. But that didn't count for anything like interactive software, video games, or stuff like that. So, but that did not prevent people from claiming that you could use Kokomo for costing and sizing video game projects, for instance. So the basic statistical problem is that you have a few numbers being used as inputs, and you have an even fewer number of parameters in output, like the duration of the project and the cost of the project. And it's extremely easy to overfit in that kind of situation, because you are coming up with an equation that fits the data you already have. And if you have enough degrees of freedom in the model, you can always end up with an equation that does that. That does not guarantee at all that the same equation is going to give you any useful or even halfway useful results in future applications. So you always have something which is good for the data you had, but you have no way of knowing if it's going to be useful for the data you will have. And that's the basic problem.
I am going to disagree on one very small part. I do not think that like trying to do any work is better than nothing here. I think that trying to create the calculus model from the start probably like was worse than doing nothing, because it tried to like force a field into a quantitative phase it wasn't ready for. Always start like the qualitative work in most fields comes way before any quantitative work can be done, and everybody just kind of just tried to skip that part.
So one tool that I know some people are using in this field is to do surveys, where they just ask people, and they ask them very specific questions about how they work, what their results are, and sit down with the people and fill that out. That seems to be, is that just a way of quantitative studying, and is it flawed that way, or is it something different, and what do you think about it?
I think it is quantitative. I think quantitative is basically just any like information where you can apply statistical measures to it to create like mathematical data. I think it gives you different kinds than say doing like a clinical trial or doing like doing code mining gives you. It's not something I've really focused on that much in my own like studies. Maybe Laurent has more information about that, but I honestly couldn't say much about like what it's good for and what it's like bad for.
Well, I think you can use, like any other tool, you can use surveys in a competent way or in an incompetent way. And so you have, I think, some data, some research that seems to be of fairly high quality is the DORA research, but it's based on surveys and has some basic limitations. And you also have some absolutely awful research that is also based on surveys. So it's a spectrum, and any type of research that you look at, even code mining, is going to be a spectrum in terms of quality.
Especially code mining.
Sorry, what was that?
Sorry, I just vocalized, especially code mining.
Well, code mining tends to be bad.
Yeah.
But it's interesting to look at why we should expect some of that research to be bad. And my way of thinking about this is to think that if I want to study something based on data, I have to look at how the data is being generated, and by what part of the process that I'm trying to study. So if you look at surveys, the one obvious thing about surveys is that you're getting people's opinions.
Yes. It is a great way to understand what people think about themselves. And that is actually very important information that we tend to neglect. And I think surveys are a great way of getting that.
And even if you do get extremely high quality information about what people think, it could be, for various reasons, completely uncoupled, unmoored from the process that you're interested in, which is the process of generating source code. Well, that's a huge oversimplification, but basically, the process that we're interested in is people starting to think about a problem and then sort of formalizing their thinking about the problem, which back in the days we used to call gathering requirements. and then structuring their thoughts about the problem some more until they have some idea of how they come to how to go towards a solution, which is a sort of thing that used to be called design, and then coming up with a program and the source code to that program, which actually solved that problem. So it's a fairly long and protracted process. The problem with surveys is that they deal with a kind of a side branch of that phenomenon, of that whole process, which is what people have thought about it. And they have all sorts of incentive to think, to have formed opinions which are wrong in predictable ways. Like they will tend to think in self-serving terms. They will tend to think that what they did was the right thing, and they had excellent reasons to do the things they did. If you look at code mining, it's something
Can I actually say a quick thing about surveys? And then we can get back to code mining. I do think one interesting nuance there is that often there is something interesting and something insightful you can learn if there's such a disagreement between the survey and reality. One really good example of this is with code review. There's been a couple of surveys I think I also put in the document where they asked people, what's the main advantage of code review? Why do you do it? And the answer is usually overwhelmingly for finding bugs in code and defects. But in terms of how it's actually observed, code review tends to most often find either serve the purpose of either improving the code quality for long-term maintenance or for spreading knowledge around in the team. And there's like that very interesting gap between what people think they're doing code review for and what they actually do during code review. And that is something interesting that people now want to investigate further. What causes that disagreement? What causes that sort of dissonance, and what does it mean? Anyway, back to code mining.
But just to add one more thing, that would fall on the competent end of using surveys for research. What I have in mind when I think of the incompetent end is more like things like the chaos research, where basically the surveys went around and asked executives, were your most recent projects successful or failed? That's a terrible way to do any kind of surveys. Why is it terrible? I always come back to what I had, the conversation I had with two close friends of mine, and we were discussing project success and failure. And I was asking, what were your experiences around that? And one of my friends said, I'm very lucky because I have only ever worked on successful projects. And I turned to the other and he says, I must be very unlucky because I can only remember ever having worked on failed projects. And then they kind of turned toward each other and said, wait a minute, but we were exactly on the same projects, both of us. And I thought, that's interesting. So that's kind of one reason you cannot trust surveys on such coarse-grained characteristics of projects. It's because people can very well have extremely different opinions on them.
Yep.
And I can actually easily relate to that because, I mean, the question, how do you define success is quite complicated, right? Okay, so...
We left code mining.
Yeah, that's also what I just thought. Have we covered that? And I don't think
we even defined it. So people, as far as people know, it's just like a term we made up.
So what is code mining and how is it useful, or should we stay away from it?
I can just quickly do this. So basically, right now, software engineering is kind of lucky among most like knowledge work in that we have a huge body of artifacts. Basically, everything on GitHub that's public. You're looking at like millions, hundreds of millions of projects. And it's now become sort of popular to sort of sweep GitHub for like large numbers of code bases and do statistical analysis on that to try to get like a slice of the entire industry. The problem with this is that the data tends to be both very complex and heterogeneous. And unless you're doing a lot of cleanup work afterwards, it's very easy to just sort of like, what's the word?
Mess up.
Do it badly? Nonsense? Laurent, do you have any? I've got a couple of examples. Laurent, did you want to interject before I launch into a couple of examples?
I think that the canonical way things can go wrong is you're trying to classify commits by whether they are fixing bugs.
Yes.
The way you do that is by using regex to find whether commit is fixing a bug by looking at the description. And so if you were, for instance, keying on finding the word fix in a commit description, that could go wrong in all sorts of interesting ways.
For example, by catching a commit that says add infix operator.
That sort of stuff.
Yeah. The same paper that I think Laurent is referring to, which was kind of a bit of a embarrassment in the general committee, at another was basically trying to compare whether certain languages led to fewer defect code, like less defect codes. And among other things, in addition to making mistakes like that, they also made a mistake like misclassifying things, like saying that V8, a C++ like system, was JavaScript, and that Bitcoin was a TypeScript project, and then including 17 forks of Bitcoin as distinct C++ projects. So any bug in that any defect in that specific code base was replicating their data set 17 times.
Yeah, V8 is the JavaScript virtual machine that is in Chrome, for example, and it's written in C++. So it sort of makes sense to, I understand why it's considered a JavaScript project, but it really shouldn't because it's written in C++, obviously.
And it's one of those projects that if they did any sort of manual work to very carefully clean their data, they would have noticed and not done. And all these things, all these mistakes they made with the infix, with the clone projects, with misclassifying projects, all sort of pointed them relying on sort of code mining and not doing all of the backbreaking manual labor that to actually make it almost kind of useful as opposed to completely useless. I mean, even if they did that work, it probably wouldn't be saying very much because they were trying to compare huge amounts of data with very broad categories. And pretty much from the start, everybody kind of thought that their results weren't that great, but these were the specific mistakes they made that made it even worse, essentially.
Mm-hmm. So what you're saying is there is this huge, there is a lot of data, but it's very hard to handle because if you're not really careful, then you end up with a huge mess. And some things, I think, for example, how GitHub classifies the projects is way off, I think.
Yeah.
Yeah, and well, I wouldn't even go into details. GitHub mentioned me as one of the most experienced Scala developers in the city that I live in, and that's just a joke because I can hardly write any Scala, so I can totally see how that works. So what I'm wondering is, what do we actually know? So maybe take one of those very fundamental questions that is, I mean, there are those religious questions about which editor you should use, and maybe the other huge religious, almost religious question, I shouldn't call it religious, that fundamental question that people really like to argue about, maybe that's the better term to use, is whether you should have a dynamically typed language or statically typed language. So what shall I do? And what's the research on that?
Laurent, do you want to start?
No, I'm going to pass on this question because I've kind of given up on having an answer even.
Yeah.
So I'm happy to say I don't know what we know, and that's it.
Yeah. So I'm going to say also I think that question is a little bit ill-formed. What do we mean by static and dynamic? Are we talking about, first of all, are we trying to compare, say, Pascal versus Python? Are we trying to compare Haskell to assembly? And then there's just a huge amount of variance in languages, and whether they use static or dynamic types is just one small part of that variance. Two, what do we mean by what should we use? That's a very vague question. Are we talking about which language leads to us creating the same projects in less time? Are we looking at which projects are easier to refactor at a large scale? Which projects are good for local things? Languages are good for local individual projects. There's just so many nuances to that question that trying to get a single yes or no answer, A or B, is not really well formed. Most of the research I've seen focuses on one very small slice. Which language do people code in? Do you get more bugs? And this is where we get, I think, one of the most common fundamental results of empirical engineering. And this is something that people sort of don't really like as a result, but I think is a good one, which is basically, for the people on the podcast, I'm making the shrug emoji. In some cases, we tend to see a lot of really strong evidence in one direction or the other, where all the studies tend to point in one direction and they all suggest the same thing. In the case of static versus dynamic, some studies go some ways, some studies go the other ways. And what that sort of tells us is that there's not a really hard and fast answer. If there was, we probably would have seen a much stronger signal. And that basically just tells people that that suggests, at least, it doesn't tell us, but it suggests that what language you want to be using probably depends on a lot of factors, and it just doesn't boil neatly down to, is it static or dynamically typed? other things matter a lot in this space too, and you just can't get an easy answer. That's not to say that there isn't a good answer for you or a good answer for your community. It just means that there's no like universal answer we can see empirically.
So in a way, so I guess, I'm not sure, would you agree with the conclusion that this means that it doesn't really matter that much? Or the conclusion might also be, if I'm an experienced Java developer, as I am, then probably I should stay with Java because it doesn't really matter, and do the next project with Java unless there are very good reasons to do anything different, because it really doesn't matter that much anyways.
I don't think the answer it really means that it doesn't really matter that much. I think that's a conclusion people draw, but I don't think it's the correct conclusion. I'd say the conclusion, and this is going to be a bit nuanced and convoluted, so give me a second to like think of it. There's the answer of what language you should use probably depends a lot on the specifics, and whether a statically typed or dynamically typed language is what you want also depends really highly on the specifics. And the specifics tend to be specific enough per project that there's no like thing you just plug into a calculator to get an answer of what language you should use. And honestly, like, not a very satisfying answer, but I think the fact that there isn't a satisfying answer here is itself an interesting insight that we have. But personally, you should use F#. Just use F# for everything. It's great.
So that sounds like, okay, so you have to make up your own mind, and research won't give you an easy answer. That's probably the one sentence conclusion from that.
Yes. Would you like something that the research does give you an easy answer for?
Yeah, definitely. So are there
Don't code
easy
sleep deprived. It's just a mess. Don't code sleep deprived.
Sorry, what was that?
Do not code while sleep deprived.
So what you're saying is that if I don't really when I don't sleep well, that influences my productivity. By how much?
Pretty significant. Like I think one clinical trial, which again, clinical trial, do not like trust a single double-blind study, suggests that like being acutely sleep deprived or being chronically sleep deprived for like several weeks basically drops you from like a senior level to a junior level in terms of the number of coding mistakes you make that like lead to bugs. And I last looked at this paper like a year and a half ago, so I'm probably getting some of the fine details wrong. But not only do we see this in software engineering, but we see this in pretty much every knowledge field, like studying nurses, studying teachers. The less sleep you get, the more mistakes you make.
Mm-hmm. Is there anything?
Oh,
sorry,
Laurent.
Laurent.
Like to interject.
Yeah, I was going to withdraw the pass on that question, because I actually have no kind of an answer to that, which is to go and look in Derek Jones's book, Evidence-Based Software Engineering, but I'm going to have to qualify that a lot. But the main reason I say I don't want to answer that question is because it depends on what you mean by we know. And I have come to expect that when people ask that, they mean, what do we know? Like, or that's extremely general. And as I said earlier, I don't think there are any such things. But if you want to look at some slices that people have been investigating, then you could do worse than just go and get Derek's book and just consider that it's the sum total of the things we know best in a very specific sense of bet. Because what Derek has been doing is been looking and obviously that's a set which keeps growing, and that's a good thing. But he's been looking at all of the data sets that were publicly available, and so you can, if you are so inclined, you can dig into the research question yourself and use the same data that the authors have been using, and you can follow the exact steps of their methodology, and you can challenge their statistical methods. The one thing you cannot challenge, alas, is the data collecting process. If you want to challenge that, basically you have no other choice but to go and collect some data yourself. But other than that, I think it's extremely good to have a comprehensive collection of the things people have been investigating and the answer that they came up with, where the data is included. It's kind of batteries included research. You have the raw data. If you want to reanalyze it, if you want to challenge the statistical methods, you can do it yourself. And so I think there are some things we know. Sadly, the thing is they do not tend to fulfill the desire for answers that prompt many people to look at empirical software engineering for answers, like questions like, is a static or dynamic typing best? Those we do not have a good answer for.
And I don't think we ever could get a good answer.
And so I have to admit that I'm quite satisfied with the answer, because what you're saying in a way is you have to make up your own mind depending on other stuff than the general scientific studies. And I have to admit that I think that's great, because it means when I'm in some situation I have to make up my own mind, and that is I think a good point. However, at the same time, what I just learned is that you should probably ask everyone whether he or she slept well every morning, and if it's not the case, then you should do something about it. And it's probably really, I mean, honestly, it seems to be something that could make quite a difference. So that's helpful, isn't it?
Yeah, I think so. There's that constant push play between things that we have sort of like a hint of versus things we're more confident in versus things that we just don't know and have to admit. I'm not sure where I was going with that.
I think the other point that I think I got it from some talk of you is about psychological safety. That this is comparable to sleep in terms of the impact on the productivity. Is that true? Or did I mess that up?
I think I was talking a bit more about like stress, and I think I know what you're referring to. And this was a study in the video game world that actually used surveys where they essentially were comparing the amount of crunch time versus how like software developers felt about the project to how well it did. And again, not necessarily conclusive information, but there's this really interesting question it raises, which is that it seems that the more crunch you had, like the worse everybody felt, like in the surveys, and the worse your game did. And it seemed to be a pretty strong correlation. And that is, of course, basically looking at a small data set with like lots of surveys and like internal information. But it is very strongly hinting, I guess it's sort of almost eyebrow waggling that like, yeah, it seems that like making everybody stressed and unhappy and like burnt out leads to just a worse quality stuff. Critics hate it more, the audience hates it more, you make less money off it. It's a neat story. Not necessarily how like much I trust it, but it does, I think, point in a direction that seems to feel fruitful.
Two points on the topic of psychological safety. One is that the topic itself became, kind of trendy when Google released results from was it Project Aristotle, something like that? I can't remember the exact name.
I know what you're referring to, yeah.
I turned my back on that when it turned out that there was no publication where they went into any detail, like the kind of detail you would expect from a scientific paper on their data collecting process. So it was more of a marketing brochure than an actual scientific study. And obviously there isn't also a release of the whole data set that you can, so that's my standard now. Mm-hmm. If you don't have the raw data, if you are not able to challenge the statistical methods, and if you're not able to get at the details of how they measured what they purported to measure, it's not worth bothering looking into. That's the first point. The second point is this is one of those topics where the intersection between epistemology, basically the study of reliable ways of getting knowledge, intersect with ethics, which is also something, an interest of mine. And the question this raises is, suppose that we had rigorous scientific studies that showed without a hint of a doubt that people made psychologically unsafe, stressed out, and so on, were more productive. Would we use that as an argument for stressing out people and putting them in bad situations so that we could reap the rewards of that increased productivity.
I mean, people already do.
Right, they haven't waited.
That's the entire sort of like cult of the crunch in like game development is that like the crunch mode is like when everybody really shines and pulls together in this stressful, unpleasant environment. That's when the true coding happens. And yeah, if the studies show that that actually was effective, they'd be blaring it from the rooftops. So yeah, I'm not saying it's a good thing. I'm just saying that people would definitely do it.
Yeah, fair point. But then, so I don't think we need, any detailed investigation to tell us that this is wrong. And irrespective of the results on productivity, we should not do that.
Reminds me about how psychopaths are more successful in a management career, which could lead to the conclusion that you should become a psychopath to become more successful in your career, which is obviously not what you should be aiming for.
I think the counterexample is it that like the top people are psychopaths, or that all the psychopaths are top people? Because it could be that like being a psychopath would destroy your career. It's just that a very, very small slice of psychopaths, basically it could be a very high risk, high reward. In which case, it's not a consistent way to power.
Yeah, I think the whole idea is so absurd that it's along the lines that Laurent said, that it's just so very unethical that you should just not do it at all. I think we shortly, So one thing that I think we know, do we know that, is code reviews finds bug. No, we talked about how this is actually different and it has a different value. What I'm wondering is when I had the first training in extreme programming, my understanding was what they said is that pair programming is continuous code reviews. So certainly pair programming should be even better than code reviews, right? Because you have two people working with one another, or even mob programming these days. So that should be even better because it's, continuous code reviews, two people looking at the code and trying to figure out whether it works or not. So is there research to back that up?
So I have two thoughts on that. One's very personal, one's much more like, I guess, empirical. The personal one is that I'm very, very skeptical of that claim because I'm a very avid writer. I do a lot of writing. And one of the really important things about writing is editing. And a very important thing about editing is that you need distance to be a good editor. You need to not have like been there while it was being written. It either has to be you like a week later, or it has to be somebody else who did not see you writing it. Because that distance and like not being tied into it so much leads to just much better editing. Now, is that true in software? I don't know. But what it does tell us is that what it does suggest is that the mechanisms that make code review effective for finding bugs, or potentially pair programming effective for finding bugs, aren't necessarily the same, right? It could be that there's qualitative differences in how people operate in those fields. And that qualitative difference could lead to one being more effective than the other. For certain classes of bugs, for certain types of projects, for certain classes of reviewers, modulo all these other caveats that always have to go in. I think I've seen a little bit of like work on that, but I don't really remember the details. But I think that before you could just say that like code review finds bugs, extreme programming is like basically code review, you'd have to sort of show that the same qualitative mechanisms, the ways people interact with the code, are the similar or same. And I don't think that's been done yet.
So basically my sort of conclusion is too simplistic because it might be something completely different, as you said. So what does that mean for all the software engineers out there? What in their day-to-day work, what is it that they should learn from empirical software engineering, except for getting a good sleep every day?
I mean, that's kind of an important thing, right?
Yeah, it is. But is there more?
Yeah, and I do really want to hear Laurent's like thoughts on this too, but I guess I can go first here, which is that there's a lot we don't know. A lot of it seems to be very project specific. A lot of people who claim that things are obviously true can't really back it up with any sort of empirical evidence. They just think it's obviously true. And what that really should tell us is that we should really be like humble about a lot of the stuff we know, because a lot of it is just based on personal experience and our own thoughts. Humility is really important. We should be skeptical of a lot of claims, and we should always sort of admit that like we're working off like we're basically just doing the best we can under a very complicated system we're not very good at. And finally, always, by God, always read the primary source.
Yeah, hard agree on that. I think the value in empirical software engineering publications is that you should read them, and they will convey a sense of how extremely difficult it is to find anything that you can generalize from. And just having that, sort of perspective, I think is valuable in itself. So my advice would be to seek and read and criticize and challenge and try to think about some papers on empirical software engineering in any area of it that interests you. It doesn't have to be one paper a day or anything like that. You can just, but whenever you come across a question that you're interested in, you can seek out and read some papers in that field and get a sense of how researchers have been approaching that topic, and that will enrich your thinking, whatever else it does. But more generally, my advice would be, my advice to people in the field thinking, what can I do to improve, would be become a systems thinker. That's only going to take you about 10 years or so. It's fairly easy. You just have to keep at it. It will give you a sense, again, it goes back to René Descartes. What do you know for sure that is going to be the case in every single case of software development that you're involved in? Well, it's going to be something that involves humans and their minds and interacting in extremely complex and extremely numerous ways. And so you can probably not go very wrong by studying complex systems as a topic and try to figure out which laws or which general insights apply in that domain, and then transpose or apply those insights back to your own local context, and maybe come up with some interesting local experiments that you can run within your team. And you're going to say something like, we've been working in this and that way, and we've been using Scrum and formal methods and test-driven development or some mix of that. And it's been working very well for us. We want to improve. I have this intuition that this local experiment might improve things for us on the, on the outcome metrics that we care about. Let's run this experiment and see what changes. And we have to be aware of our own biases as we do that, our own tendency to overinterpret and to interpret things in rosy, self-serving ways. But as we keep that that perspective, we can always try to make the best from our local experiments. That's the kind of thing I would recommend.
Yes, read for insight and read for the interesting thoughts. Don't read for easy answers.
And experiments, I guess, would also mean that you would define some KPI that would be improved by the experiment, or some hypothesis that says this is the KPI that should be improved. Or is that too far? Would you rather aim for discussing the results of the experiment afterwards and get some subjective ideas about from the team?
That's what I'd prefer personally.
But also beware metrics. That's
do both.
Okay. Finally, yeah. So I'm a consultant, and I do recommend things. That's basically what I'm being paid for. And obviously, in most cases, there is no good scientific research to back up what I'm recommending. So, is there anything that I can do to improve?
Well, I'm also a consultant, and I also recommend things that I think based on like what works. And I'm in the same boat, especially because like the stuff that I work in tends to have like very, very, very little empirical research. And ultimately, I think that's just part of what being a human is. Like most of the stuff we do, we can't really easily study. We have to find like alternate ways of finding confidence. And the way that I found to find confidence is to like, one, be very humble about what I know and what I don't know. And two, be very explicit about what I can and can't promise. And I've turned down clients by saying like, look, I've seen people in similar situations try these things. It did not work for them. I do not think it would work for you either. basically just admit your own fault and basically, yeah, I didn't know how I was going to finish that.
Stay humble.
Yeah.
One thing so I'm not sure what you think about this. So one thing that I try to do nowadays is when I look at some situation, let's say, I don't know, there is some data structure that everyone uses in that project, and I think it's a bad idea. And my conclusion would be that using that centralized data structure would make things hard to change. And then instead of saying, well, you should really solve that problem, my approach is rather to tell people, well, this is what I expect should be happening. And then I ask them whether they see that, and if they don't, then I don't recommend to fix the problem. Is that something that is somewhere related to this? Is that a best practice? Would you think that this makes sense because it's so very complex, or is it something that is completely unrelated to what we have been discussing?
You could approach that kind of situation the same way you would if you were writing a research paper on it. And so you would have the same kind of overall questions to ask. What would we be measuring to know whether the proposed change could lead in the direction that we desire or not? So is this measurement going to be contaminated by problems like confounding? Does it have any danger of being distorted by bias? And then the next set of questions is, suppose we run this experiment and we get this kind of outcome. How do we interpret that? So you have to think ahead to how you are going to interpret the results. So you could get a lot of inspiration from looking at research papers and the way they approach a question, keeping in mind that the scientific method is designed to avoid researchers fooling themselves into thinking they have answered a question when they haven't. And so this is exactly the same kind of thing that we want in local investigations. We want to be able to tell if we have fooled ourselves into thinking we have answered the question when we haven't. So that's one way you can go about it.
I'm asking, like, why are you getting my advice? You've been a consultant a lot longer than I have. Like, I should be asking you advice about this. I mean, I guess my thought in that case would be that seems like a much more like single individual event. Like, is this going to be a bad idea, or is this specifically going to be a good idea? And that's like kind of a bit outside the scope of like empirical research. What I might try to do in that situation is basically say, like, here's what I predict. If this happens, here's some ways you can mitigate it after the fact. And if they don't believe you and then like it ends up going wrong, then hey, you've shown that like you can predict in advance what's going on. That's cool. And you've also given them help in advance to what to deal with. That's also cool. And if nothing happens, then, well, everything was good. Great.
Mm-hmm. Okay, so anything that you would like to add? We are a little bit over the time. So
are you going to share like a list of links? Because I definitely Leprechauns of Software Engineering, it's on leanpub, leanpub.com/leprechauns.
So yeah, I will definitely, I guess this episode has the potential to have the longest list of links ever. So at least in the documents that we shared, there are quite a few of them. So the Leprechauns, I need to research the book that you, Laurent, were talking about from, what is it, Derek's book. So I need to research that. And also there is the talk that you, Hillel, gave about what we know and what we don't know, and where you walk through some of the papers. So that is also something that I would definitely link and that I can highly recommend. So there will be, and then there are the primary sources, all the papers. So there will be a lot of stuff. And also the page with your talk, links all the original papers, which I thought was quite great and I've never seen before. So that's also something where you can investigate further.
I mean, if people listen to my talk and go like, I believe everything you said, then I failed.
And I think that's probably the best way to end this episode with this statement. So thanks a lot. It was really a pleasure. It was a very interesting discussion and I learned a lot. Yeah, that's pretty much it. I'm afraid there won't really be any English-speaking episodes for the time being. So on Thursday we will have an episode about documentation, and on Friday we will have an episode about functional programming, but those will be in German. So sorry about that, and have a great evening, morning, day, whatever, and talk to you soon. And thanks a lot.
Bye. Thanks, everyone.
Thanks, everyone. Enjoy the rest of your day.